Hello and welcome to the Chemistry Academy. In this video we're going to go over electrophiles and nucleophiles in relation to the Advanced Higher Chemistry course within the Organic Chemistry unit. So electrophiles and nucleophiles tend to confuse people, but it's actually very straightforward in terms of how to identify which is which. Well, I think it is, but maybe I'm biased. But it's essentially based on what they are attracted to. So electrophiles means that it's electron loving, so it loves negative charge, and we know from even doing National 5 chemistry that opposite charges attract. So if you have something that is attracted to negative charge or loves negative charge, then that thing itself is most likely going to be positive or lacking in negative electron density. So if we look at some of the common electrophiles that you come across here, you might notice that a lot of them have positive charges, but sometimes you can get one like SO3 where it's just because one of the atoms, like the central atom in the molecule, is electron deficient. So this sulfur's got 3 very electronegative oxygens attached to it that's pulling electron density away from it. So that leaves the sulfur atom electron deficient. So that would be an electrophile as well, because that's going to be partially positive. So if you remember from higher when you did polar molecules, the oxygens are more electronegative than the sulfur, so they'll all be partially negative, thus leaving the sulfur partially positive. So again, that's going to be attractive to attracting any negative electron density. So if you're looking at something and trying to find out if it's an electrophile, look to see if it's got a positive charge or if there's a central atom that is bound to a lot of other extremely electronegative atoms. If we then look at the nucleophiles, nucleo means nucleus, so the nucleophiles are nucleus loving. Again, we know from National 5 chemistry that the nucleus has an overall positive charge. So this means that the nucleophiles love positive charge. They're attracted to positive charge, which means that they themselves tend to either be negatively charged ions or molecules that have lone pairs of electrons, or even potentially pi bonds, because there's a lot of electron density held within a pi bond. So if we look down this list of common nucleophiles here, there's a lot of them that are negatively charged ions. So if you see a negatively charged ion, that can be classed as a nucleophile. I often try to remember like nuke, negative, they both start with an N. And then water and ammonia, we looked at them in transition metal complexes, and we learned then that because they've got lone pairs or non-bonding pairs of electrons, they can form dative covalent bonds with metal atoms and ions. So this is therefore why they're classed as nucleophiles, because they have lone pairs of electrons that they can then donate to make covalent bonds with other positively charged substances. So they're technically partially negative because they've got these extra pairs of electron density. And then there's C2H4, so that's actually ethene. So if we draw that out, like I said already, pi bonds carry a lot of electron density with them. So this pi bond here is very electron rich, which means this would be classed as a nucleophile. And then down here we've got an amine, which again, it's got the NH group on it. So anything with an NH in it, there'll be a lone pair on the nitrogen, so that could be used as a nucleophile as well. So it is pretty straightforward. You're really just looking at, most of the time, the charge of the substance. If there's no charge on it, look to see if it's got any double bonds or lone pairs, because it will commonly be a nucleophile. And just try to remember that SO3 is an example of an electrophile that doesn't have a clear positive charge on it. And most of the other ones you will see will probably be positively charged substances. So, like I said, I personally remember nucleophiles are negative because it's N and N, but it's up to you if you want to come up with another way of remembering, if it's to do with the electrophiles loving negative electron charge, electron density. It's up to you. Just find a way that works for you to help you remember which way around it is. But the moral of the story really is, if you're trying to identify an electrophile and nucleophile, just look at whether it's negatively charged or positively charged. So really short one for this one, but I hope it helped. If you found this useful, please give the video a like. Don't forget to subscribe, and I'll see you again soon.